All right, welcome everybody to the Murray Amateur Radio Club. This is our second instance of our Back to Basics series that we're doing this year. Last year we did kind of a introduction to ham radio and a ham for beginners type of thing, but we're going to just kind of take a step back and learn some really basic stuff about being a ham this year. And so first thing we're going to talk about today is basic VHF and UHF operation. So let me see if my slides are going to work. So Dan alluded to the fact that I'm at work. I actually tried to get home and spent 45 minutes driving in a big circle and made it back to the office. So I gave up and I came inside and figured I'd just do it from here. So anyway, Murray Amateur Radio Club's Back to Basics program. It's the goal is to activate new hams and reactivate inactive hams. When the club started, a lot of people who came had had their license for a while, but had never talked on the radio or seldom talked on the radio. And so our goal was for the Murray Amateur Radio Club was to get some of these hams talking on the radio again. This year, these classes are going to be designed for non-technical people. We want these to be easy to understand. We want these to be easy to work with and learn. The kind of the goal here is we want Dan to be able to understand it. So that's our target. We want people to get involved and have fun with amateur radio. Now, if you want to teach a class this year, let me know and I'll get you on the schedule. If there's a subject that you're interested in, let me know. If there's something that you don't understand in one of the presentations that you see, ask for more information and we'll dig into it. If we need to have a separate class on some particular topic, like how to program your radio, we will have a separate class on that just to make sure that people understand what they're doing. We're going to talk about that a little bit tonight, but I just want everybody to know these classes are for you guys, and we want you to get comfortable with your radios, get comfortable with talking on the radio, and actually get on the radio. So we don't want the radio to just sit on the shelf, and then when you need it, you pick it up, the batteries are dead, and you don't know how to work it. That's not going to help anybody. So that's kind of our goal for this year. So let's talk about basic VHF and UHF operations. So first, what are VHF and UHF? How are they the same and how do they differ? How do I set up my radio? How do I operate my radio? What is simplex? How does it work? What's a repeater? How does it work? What do I say? And what do the things mean that the other people say on the radio? These are the things that we're going to talk about tonight. All right. So let's talk about VHF. VHF stands for very high frequency. We normally talk about VHF in regards to the 2 meter band, which is 144 to 148 megahertz in ITU region 1. Now, the world is divided into three ITU regions, 1, 2, and 3. Region 1 is where the um, Europe, Africa, and Russia are, and they limit this band to 144 to 146. ITU Region 2 is where the Americas are, and ITU Region 3 is the Asian and oceanic part of the world. So when we talk about the ITU regions, that's what we're talking about, is how the world is split up into segments. And ITU Region 2 is where we are here in the US. And the bands are a little bit different sometimes in the different regions. So we'll talk about that as we encounter those differences. The 2 meter band, we normally use FM, which is frequency modulation. There is some single sideband and CW used on this band, but we'll talk about these things in a second. So don't panic when you see these acronyms. But there is some SSB and CW on the lower parts of the band, but it's mostly FM. The band has characteristics that include that it's mostly line of sight. It's limited by terrain and obstacles. So if you can visually see the person you're talking to, whether they're 5 miles away or 25 miles away, maybe they're on top of a mountain or something, then you can get a good solid signal to them. The maximum range is about 100 miles, and that's more because of the curvature of the earth than the power of the radio. Okay. Um, all of the license classes except novice can use this band. So technician, general, advanced, and extra class. Let's talk for a second about license classes. There are 5 recognized license classes here in the US. 3 of them are still able to be actively gotten, as it were. So you cannot get a new license class of advanced or novice anymore. But if you had a novice or advanced license and you kept renewing it, you might still have an advanced or novice class license and still be restricted to the privileges of those license classes. Most people, when they first take their tests, they're going to become a technician. There are 3 tests that have to be taken. For the element 2, and here's another thing that confuses people. Why is it element 2 if it's the first one? Well, element 1 was the Morse code test, and that used to be required for all of the license classes. And back in it was either the late 90s, early 2000s, they took away the requirement for technicians to have code. And then later they took away the requirement for generals and extras to have code. So element 1 is never used anymore, but it still exists and it's still called element 1. So element 2 is the test for technician. Element 3 is the test for general, and element 4 is the test for extra. And again, you cannot get advanced or novice class licenses anymore. If you want to get a general, you have to pass both element 2 and 3. And if you want to get an extra, you have to pass all 3, element 2, 3, and 4. All right. The typical radio you're going to use on VHF is a HT, what we call an HT. HT stands for handy talkie, and that's a handheld radio. I'm sure Dan has a handy talkie in front of him that he can hold up and wave about so you can see what it looks like. Yeah, the other type of radio that is typically used is a mobile radio, which is what we call a vehicle mounted radio. Now, are there base stations that do VHF on 2 meter band? Yes, there are, but most people, for doing that at home, they will use a mobile radio mounted up at home and running off of either a battery or a power supply of some kind. So you'll typically see either a handy talkie, or an HT, or a mobile. They're often used for both simplex and repeater operation. We're going to talk about both of those in a minute. And they can even be used for satellite communications. So we'll talk about that too. There's also another band in VHF called the 1.25 meter band. This band in the US is 222 through 225 megahertz and 219 through 220 megahertz, which is kind of weird. There's a gap in the middle there. It used to go all the way from 219 to 225, but it wasn't heavily used, and the FCC decided they could make a little money by selling 2 megahertz of this band out of from under us and selling it to, I think it was cell phone companies or somebody like that. I don't know who got it, but in ITU Region 2, remember that's where we are, the Americas, Greenland, and the Pacific Islands, and in Somalia, which is actually in ITU Region 1, the 1.25 meter band is used in those areas. It is not used in ITU Region 3 or in most of ITU Region 1. So Europe, Russia, those guys don't use this band. Only Somalia has activity on this band out of Region 1. It also uses FM, or frequency modulation. It is line of sight, but it's got some interesting characteristics. It can follow some terrain features and it can penetrate buildings better than 2 meters. In fact, we've had some experiences where Dan was out on I-80. I don't know how far out you were, Dan, but quite a ways west of Salt Lake and still able to hit our repeater, even though there's a mountain in the way. So
I was in Twilla,
you were
going
in
down Main
Tooele.
Street.
Okay,
I was in
so
Twilla, going, and
five,
I'm going over the mountain.
45, 50 miles away with a mountain in between him and our repeater, and he was still able to hit it. So it has some interesting characteristics. Let's put it that way. Um, the technician, general, advanced, and extra class can use this band, and the novice class can also use this band, but only at 25 watts. So this band can be used by all license classes, including novice. And that's kind of a weird thing because novice doesn't normally get to play on VHF, but on this particular band, they do. The typical radio for this is also an HT or mobile, and it's often used for both simplex and repeater operation. And in fact, it's often used for repeater linking and control frequencies. So if you've got two repeaters that are working together, you can link those two together by having a separate radio link between them. And anything received by one repeater will be sent out by the other one as well as itself, and vice versa. And so it can give you a little wider area. This band is typically used for those linking and control frequencies. So UHF is the ultra high frequency band, and this is what we call the 70 centimeter band. Now, why do we say like 1.25 meters or 2 meters or 70 centimeters? This is actually the length of the wave itself, the wavelength of the signal. So if you think about wavelength and frequency, they have an inverse relationship with the speed of light. And if you take the speed of light and divide by the wavelength, you'll get the frequency. And if you divide by the frequency, you'll get the wavelength. So it's kind of interesting how that works. But on the 70 centimeter band, we're running at 420 to 450 megahertz in the US. Many countries only allow 430 to 440 megahertz. And even in the US, some portions of the band are not available in certain geographic areas, like along the northern tier of the US and some along the coast, because there are government radar systems that are just outside this band that can be interfered with by this band. So you have to stay away from the top of the band in those locations. It also uses FM, frequency modulation, and is line of sight, but it can penetrate buildings better than 2 meters. I don't know if it's better than 1.25 meters or not. I haven't ever done any tests on that. Again, the maximum range is about 100 miles. Only, well, if you're a technician class or general or extra, you can use this band. A typical radio is again an HT or mobile, and it's often used for both simplex and repeater operation, and it's used for link frequencies as well. So let's see. So let's talk about modulation for a minute. I've been throwing around this FM and that kind of stuff for a minute. Let's talk about what that actually is. So modulation refers to how the signal is your voice, right? That's you talking. How that signal is modified to carry the information. Sorry, the information is your voice. The signal is the radio frequency. Common modulations you'll see are FM, AM, SSB, and CW. So FM is frequency modulation. It uses a section of the frequency spectrum at a consistent power level. So that's one thing to note. And the variations in the wavelength carry the information. So it's always at the same power, but the frequency is changed during the transmission. So this message signal, which is the audio signal, is imposed on this carrier signal and modifies it by adjusting the frequency and wavelength. That's what's called frequency modulation. Okay. So if you can see how that works. AM is a little different. With AM, the frequency stays constant, but the strength or the power of the wave is varied to carry the information. So again, we have the signal up here, and we have a solid carrier wave going on. And then you see the wavelength is the same, but the amount of power carried by that wave varies in line with the signal that we're transmitting. And you can see the signal is imposed on both the top and inversely on the bottom of this transmission. That's an important thing about AM, and it becomes important in our next particular modulation here, which is single sideband or SSB. So what single sideband does is it says, hey, you know what? Look at this signal. I have the same information up here as I do down here, except it's upside down. Okay. So instead of doing that, here's my AM signal, right? I've got a carrier signal and I've got the information out here. Instead of doing that, I'm going to suppress the carrier and half of that and only use half of that signal. Okay. So I can either use the upper sideband part like it shows here, or I can suppress the upper sideband and use only the lower sideband part. Different bands are going to use different, either the upper sideband or the lower sideband as the normal transmitting band or transmitting modulation. So that's the difference, right? It's single sideband. You're, instead of having both sidebands, you've only got a single one. All the information is in there, but you're suppressing the part that you don't want to transmit. And because you're suppressing both the carrier and half of this signal, you actually get 4 times the signal strength for the same amount of power that you're putting out. So you'll see a lot of these radios that say we do 100 watts on single sideband, but only 25 watts on AM. Well, that's why, because the radio has a certain amount of power. And if you're doing the AM, you've got to spread that power across the carrier and both sidebands. If you're doing single sideband, you're only spreading that power across one of the sidebands. So that's why it's an advantage to use single sideband. All right, let's talk about CW for a second. So CW is what we call continuous wave. Basically with CW,
Jan, just 1 second.
go ahead.
An observation, the real motivation for single sideband is that your signal is only half the width, and therefore you can cram twice as many signals into the same amount of space.
Yeah, good point, right? So if you look at this diagram here, right? I'm using this part for my signal. I could fit another signal in here. It's going to still be an upper sideband signal with its signal center being over here, for example. If I'm running AM, I'm taking up twice as much space. You can see I'm using up space in the band all the way on either side of this carrier, right? All right,
That's called bandwidth.
bandwidth, correct. Okay, so let's talk about CW for a second. So with CW, I've got my data coming in. It's either ons or offs, and it's coming from either a key or a keying device that is producing the Morse code, the dots and dashes. Now, if it's a dot, it's going to be a short pulse. If it's a dash, it's going to be 3 times as long as a dot. There's no dashes on this diagram, but you can get the idea. A dash would be nothing and then signal for 3 times as long and then nothing again, right? And so what happens is when you've got the signal part happening, you transmit the signal. And when you don't, you don't. So you can see it's either transmitting signal or it's not transmitting signal. Don't worry about this FSK thing down here. I couldn't find a good diagram of this that didn't have this on it as well. So I kind of left that in there. I was trying to figure out a good way to crop that out, but my graphic skills are not as it's not as good as my radio skills. Let's put it that way. So I'm gonna ignore FSK for now. We'll probably cover that in another class down the road. But with CW, you could either think of it being the signal is there or not there, and it's used for Morse code transmissions. Now, there's another type of CW called MCW, or modulated continuous wave, which is basically an audio signal just like this, but the sound that it's carrying is the beeps. Okay. So if you ever are on a repeater and you hear the repeater beeping Morse code at you, that beeping is a MCW signal. It's a modulated continuous wave, and it's really just an audio signal. Okay. It's not anything special about it. It's just an audio signal carrying Morse code. Okay. All right. So let's move on to how do we set up our radio? What have we covered so far? Um, we covered what are VHF and UHF, how are they the same and how are they different? Now we're moving on to how do I set up my radio? Okay. So let's dive into setting up my radio. So there's a few parameters that you need when you're setting up your radio. The first one is the band. What band are you going to be using? Remember, we talked about 2 meter, we talked about 1 1/4 meter, we talked about 70 centimeter. Those are different bands. Now, the 2 meter and 1 1/4 meter are VHF, and the 70 centimeter is UHF. That doesn't really matter as much as the fact that they are different bands and they're different wavelengths, essentially. You'll need to know what band you're going to be using. You'll need to know what kind of modulation you're going to be using, right? You may be using FM. You're most likely going to be using FM. You may be using single sideband. as a technician operator, we do have some privileges on other bands, not just the VHF and UHF bands. In fact, we have privileges on 10 meters, but interestingly enough, 10 meters uses either a single sideband or FM, but as a technician, we can only use single sideband. We can't use FM on 10 meters. So that's something to consider, is make sure you're being legal in what you're doing based on what your license allows you to do. So you need the band, you need the modulation type, you need the frequency that you're going to be transmitting and receiving on. You might need a tone, and we'll talk in more detail about the tones in a minute. But it's basically a subaudible, which means you can't hear it. Some people can hear it, I've heard, but my ears can't hear it. It's a subaudible tone, and we'll talk about what that does in a minute. Or there may be a digitally coded squelch tone in there. And you need to be able to configure how much power or how much energy your radio is going to use to produce the signal. And there are some other factors to consider as well, like what antenna you're going to use, how you're going to power your radio, that kind of stuff. We probably won't dig into that too much, but those are potential factors. All right, so setting up the radio. The first thing you need to understand is that most radios are going to have memories and what we call VFOs. So what's a VFO? A VFO stands for Variable Frequency Oscillator. So when I talk about a VFO, think about the actual radio inside your radio, okay? The part of your radio that makes the radio signal. Some radios have more than one VFO. Some radios like to pretend that they have more than one. So Dan, I don't know if you have a TH350 there, but if you do, you can hold that up for a second and show that the 350 has three separate lines on the screen that show a frequency, but it really only has one VFO. So even though it has three different frequencies showing, it can only work on one band at a time.
So, Jan, I'm holding up the new KG935H hotel. That's the Ocean Tri-Band. And it has two VFOs in there. So there are two radios in here. I can hear both people talking at the same time on two different channels. Other radios that have a single VFO but have multiple channels, when one band or when one channel is talking, the other two are muted out because it can't do more than one. So those are the two different type of radios that are possible out there.
Yeah, so depending on the radio that you get, it may have multiple VFOs. It may pretend to have multiple VFOs, in which it gives you a couple of ways to say, well, I want to listen to two different channels. It'll let you do that to a certain extent, but like Dan says, if it's only got a single radio in there, it can really only listen to one at a time, okay?
A common technique that they use is like my Yaesu FT M100. It's a dual band radio. It has two channels, but has a single VFO. And what they do is they'll go ahead, if you want to listen to a particular home frequency, you put that in there, and then whatever frequency you're listening to, it'll every 5 seconds do a quick check on that frequency. But he's still using one at a time, and so that's what some of these radios try to do, is to quickly scan the next one. Yes?
So you have to be really careful when you're buying a radio. Read the marketing blurb with a grain of salt. A lot of manufacturers will advertise these radios as dual band. A true dual band radio can listen to both channels at the same time. What I like to call a twin band radio, you can listen to one or the other at a time. But a true dual band, you can listen to both.
Right, so...
You have to read the specs very, very carefully before you buy.
Well, and you have to know the source of the specs, because I can buy a radio, HT, with 20,000 watts. It's on Amazon. It's on What? Yeah, some Chinese place, 20,000 watts. Yeah.
Advertise
So
for that,
be
right?
careful. Be careful.
Yeah, it's not going to actually have 20,000 watts. So, all right. So, the thing to be aware of is that the VFO that you set up has all of those basic parameters in it, the band, the frequency, the tone, etc. And you can put all of those in manually on your radio. Okay. Now, the memories allow you to store that configuration. So you might have some settings that you use all the time. Maybe you listen to a particular repeater and it is on a certain band at a specific frequency with a specific tone. And so you can set that up and save that into a memory location in the radio. Some people call them channels. I usually call them memories, but you can also think of them as channels. And that allows you to easily go back to, if you've gone to a different frequency, you can quickly go back to the one that you like just by loading that particular channel or that particular memory. Different radios are going to have different numbers and configurations of memories. So, like the typical Baofeng, I think has what 127 memories or 128. My Kenwood has like 1,000 that I can program into it. Um, and it depends on the radio. And again, you get what you pay for. So you might pay attention to when you're looking at the marketing literature for a radio, it should tell you how many memories it has. And just to clarify, as was said, sometimes that marketing literature was not written by somebody who knows what they're talking about. And so it's also a good idea to look at reviews on these radios, or some hams will buy these radios and they will do a video where they talk about the radio. Look one of those up and watch the video, and you'll see something about that radio that you may not have found in its marketing literature. So it's always a good idea to do your research before you lay down some money on a radio. Okay. So, how do we set up a radio? You can put your radio in VFO mode and manually set all the parameters. You can save that setup into a memory that you can access later, or you can use a computer to program the memories to contain the information for a bunch of different settings or a bunch of different frequencies and channels and things that you want to use. So, we're going to talk about both of those things. So, manually programming your radio from the front panel, you need to learn how to do this for your radio. Okay. If you ever find yourself in a situation where someone says, hey, switch to channel X, and you don't have channel X programmed into your radio, you'll need to know how to program your VFO for the parameters that you need. And every radio, every manufacturer has their own way of doing this. So you'll want to spend some time with your radio's manual. And yeah, sometimes the manual sucks. A lot of the manuals are really, really, really bad. Most of them are okay. Some of them are really, really good. But this is just a fact of amateur radio life. Because these radios are not um, being sold to the general public, there's an assumption that we have a certain amount of knowledge about how to work things like radios. And if you're licensed, you should have some idea how it works. It doesn't mean that it's hard to actually configure the radio itself just because the manual is bad. But what it does mean is you may have to look for other resources to help you learn how to do it. And you need to practice doing it so that you are comfortable doing it on your radio. Now, I'm not going to give specifics about programming a bunch of different radios. We'll talk about that in a second. But
Hold up, Jan.
yeah,
I just want to put in my plug. Anytime, and this is something that you've heard me say a billion times, anytime I buy a new radio, without exception, I will program the first 100 channels manually. Okay, forget about the computer. I spend $50 extra for the computer software, but I will manually do it 100 times so that I have memory muscle. So that it doesn't matter what radio I use, and I have about 20 separate different HTs. I can go in and program any one of them at any time without thinking about it. Why? Because it was a pain to do the first 100, but there's a lot of benefits in the end. When you're out in the field, You may not have your computer with you. You may not have the manual with you. The only thing that you may have with you is your senses, right? And what you've learned. Exactly. So, take it or leave it. Some people will rely on the computer, and that's fine. I'll end up programming their radio. And believe me, it happens a lot.
I recommend you take the time to learn how to program your radio. And again, different radios from different manufacturers are going to have different ways to do it. So you need to take the time with your radio or the radio that you're likely to be using, figure out how it works and figure out how to program it manually. Because when you do need to do it, you might be in a hurry, you might be in a life or limb at risk situation, and you might need to do something really fast. And if you don't know how to do it and you're trying to flip through the manual and figure it out at that point, that's not going to be very fast. Trust me.
Let me just give you a real world example that actually happened. I belong to the ARES group, Salt Lake County ARES. They did a joint thing over in Tooele, the Tooele County ARES. They had everybody in Tooele go to the EOC there, and we were doing a high wind drill, a lot of power lines down, radio towers down, etc. And so I'm the only Salt Lake County ARES member there. The rest of them are Tooele County. This is their EOC on Main Street. If you've seen the big ham radio, HF radio on top. So I go in there, and they're looking at an ICOM IH880 hotel, ICOM VHF UHF radio. They look at it. They're looking around. Does anybody know how to program a frequency in there? This is in their EOC. And it turns out I have the same radio in one of my Go kits. And yes, I programmed the first 100 channels manually. And so guess what? The Salt Lake County ARES dude programmed the Tooele County's EOC radios. Now what's wrong with that picture? Anyway, there you go.
Yes, it was a good thing you were there, because otherwise they wouldn't have known what to do with that radio, right? So yeah, figure out how to do it with your radio. Okay, so programming memory channels, typically you'll program the VFO and then you'll save it to a memory. And again, different radios have different ways of doing this. On my Kenwood, there's a button called M in, and I hit that and zap, it's in the memory. On the Baofeng, I have to go into the menu and find the save thing and hit that, and then it'll save it to the memory location. But it depends on the radio. So different radios have different ways of doing it. Now, the alternative to manual programming is to use programming software. All the radios that you're going to find are going to have some software that comes with them that can be used to program the radio. Well, it may come with them. It may cost extra, okay? This type of software will generally be for Windows only, which is fine for most people, but not everybody is a Windows guy. And you will need a cable that is compatible with your radio. So something that will go between the computer and the radio and allow you to communicate between the two. There's also a package called Chirp, which is a free open source package, and it has the ability to program a large number of different radios. I think last time I looked, it was over 300 types of radios that it knows how to do. And then there's a company called RT Systems, and they sell several packages that work with a variety of different radios, but they do require that you use their proprietary cable. That's how they make their money, by selling those cables. And the save file on RT Systems is compatible with any radio that you use. So if you program up one radio with RT Systems, you can save that same set of channels into all of your radios as long as they're supported by RT Systems. I know Dan uses RT Systems. I've used Chirp primarily, but I also use the manufacturer software as well. It just depends on the radio what I'm going to be using. So
when you do have a lot of different radios, using RT Systems is great because, like Jan already mentioned, I can have Yaesu VX6 with RT Systems on my computer and KG 935 Hotel Ocean, completely different manufacturer, with RT Systems right next to it, and I just copy all the channels here and it will paste it into the completely different manufacturer radio, and it knows which parameters to change, which options go where. Talk about a time saver. So when I buy a radio, I automatically assume I'm going to spend another $50 because for me, it's worth it because programming, inputting 800 channels on chirp, for me, I don't want to do. So anyway.
All right. So how do I know what frequencies to program into my radio? I'm sitting here, I've got the radio, I've got the manual, I've figured out how to program a frequency in. What frequencies do I put in? Well, there's a few different places to find out. There's a site called Repeater Book, and they have an app as well for your phones or tablets or whatever. And you can go there and they have like a list of repeaters all over the place. So you can find a repeater in the area where you are, and it will have the information that you need to program in. Your area frequency coordinator may also maintain a list. In Utah, that's the Utah VHF Society. They maintain that repeater list, and I have the URL right here where you can find it. Your local club or your local areas organization may maintain a standard load file of frequencies that you can put on your radio. Mark has one of those. You can find it at that URL right there. These slides will all be published on the website. So if you want to take a picture of this, you can, but you don't necessarily need to. You'll find it on the website afterwards. You can also ask other hams in your area what repeaters they find useful, and APRS may be configured to publish repeater objects that you can load into your radio. Or you can ask a local ham to help you program your radio. We'll do it for you during a club meeting if you bring your radio and programming cable.
One of the things that some of our visitors are expecting here, and because I advertised, was we've developed a new version of the standard load, the Salt Lake County Area standard load. On this new standard load, I actually have it's an Excel spreadsheet, and there's a tab, a worksheet, that has all of the Utah repeaters as found in the Utah VHF website. So every single 70 centimeter doesn't have to be in Salt Lake County. It's in Washington County too. Everything. So get that standard load for me, and it has not only what Salt Lake County Aries uses for Salt Lake County, what all the clubs are using, and what the emergency management systems are using, but also Utah VHF Society's download is there, plus a group of simplex frequencies that are identified, plus the intertie, all the maps of the 4 intertie systems that are contained within Utah. So all that is in the standard load. And so after this presentation, just come with me and we're ready to download things into your radio.
And can you send me a copy of the new standard load, and I will update the website as well?
Yeah, you got it.
All right, sounds good. Okay, so let's move on to operating our radio. So how do I work my radio? I've got this nice radio. I've now got it programmed. Now what do I do? Well, it depends on the radio again. So with a handheld radio, again, you'll need to refer to your radio's manual. There will be a way to turn the radio on and off. It might be a button on the front of the radio. It might be a knob on top of the radio that you have to twist. It will depend on the radio itself. You'll want to adjust the volume. On many handy talkies, or HTs as we call them, the volume knob is integrated with the on-off switch. So you'll turn the switch to power it on and then keep turning to turn the volume up. You'll want to put the radio in VFO or memory mode, depending on what you're doing. If you're in VFO mode, you can often enter a frequency directly with the keypad on the front of the radio. The other parameters, like the tone and things like that, might be slightly different. And we'll talk about that in a minute here. In memory mode, you'll either find buttons or a knob that can be used to select the channel that you want. Sometimes you can directly enter the channel number using the keypad if you're in memory mode. Mobile radios are similar, but the keypad will usually be on the microphone, and sometimes the buttons will be in different places depending on the radio. Some radios will have more knobs than others. Some radios will have like two tuning knobs and two volume knobs, one for the A VFO or the left side VFO, and one for the B VFO or the right side VFO. So it just depends on the radio, and you'll need to drag that manual out and figure out where the controls are for your radio. The radio will be in listen mode by default. Now, when I say that, I don't mean the radio is listening to you. I mean it's listening to the radio waves, and whatever it receives, it will kick out the speaker. You might need to adjust the squelch. So what the squelch is it's a setting that basically says, hey, if there's no signal, don't make any noise at all. Okay. A lot of radios will have a monitor mode where you can turn the squelch off momentarily. Sometimes that can help you find or hear a signal that is really weak. But in general, you want a strong enough signal to break the squelch, which means open the squelch on the radio so that you can hear the signal. And you may need to adjust that squelch setting depending on the strength of the signals that you're trying to receive. And again, different radios are going to have different ways to do that. Some of them you have to go into a menu and adjust the squelch there. Some of them, there's a knob right there on the front panel that you can turn. It depends on the radio. When you're ready to talk, you're going to hold, if it's a handy talkie, you're going to hold the radio straight up and down in front of your face. Why is that important? You want the antenna to be straight up and down, or as close to straight up and down as you can get it. I don't know if you've seen some of these videos where people are like holding the radio on an angle and the antenna is pointing off to the side. It will still probably work most of the time, but you're not going to get as good of a signal out because the energy coming out of the antenna comes out at a 90-degree or perpendicular angle to the antenna. So if you're pointing your antenna off to the side, most of your signal is going up into the sky, or it's going right down into the ground and not going where you want it to go. So you want the antenna straight up and down, and then you're going to push the PTT button. So there's a little button on the side of the radio that's typically labeled PTT or push to talk. You're going to push that in and then speak clearly and distinctly into the microphone. You might
Stand by, Jan.
go ahead, Dan.
Yes.
An important consideration, I shouldn't have to mention this, but I've seen enough uh, novices, not novice class, but radio novices who seem to think that this is a handle, and they use it to pick up the radio, and sometimes I even see them swinging the radio around. That's a really good way to ruin your radio. So if you are in the habit of doing that, break the habit before you break the radio.
I assume you're demonstrating holding the radio by the antenna.
Yeah, he just broke his radio.
Bad on a bunch of levels, right? Because uh, you may get away with it for a little while, but that the connector that the antenna screws onto is not always the strongest point on your radio. And so that can break and that can cause you much grief. And if your hand's on the antenna and you start transmitting, that RF energy is going right into your hand. That's probably not where you want it to go. So, it's a good idea to get used to holding the radio correctly. Hold the radio by the body of the radio, and when you push that button, you're going to talk directly into the microphone. Or you may find that you actually sound better on the radio if you hold the radio at a 90-degree angle in front of your mouth and kind of talk across the mic rather than directly into it. I've noticed that if I'm talking directly into the mic, I can get a lot of popping noises, and sometimes my voice overloads the microphone and comes out really garbled or really loud. And so if I talk across the microphone, then I get a better reception of my signal. That again might depend on the radio. So if you've got two different radios, one of them you might have to talk directly into the mic, and another one you might have to talk across the mic. It just depends. And that's something that, since you can't hear yourself on the radio, you'll have to have somebody else tell you, hey, your signal sounds really bad. And when they do, you can try moving it around a little bit and try again and see if that's better. Now, the next thing is really important. don't forget to let go of the PTT button. Sometimes we call it the RTL switch or release to listen switch, but you don't want to hold that down after you're done talking because when you're holding that down, you are transmitting and you can't receive while you're transmitting. So make sure you let go when you're done talking. You'd be surprised how many people stand there and hold the button down and they're like looking around and saying, "Can't anybody hear me? Nobody's coming back." I hate movies because they don't understand how radios work. And you will often hear, somebody will be talking and the other guy will pick up the radio and just start talking into it. And magically, somehow, they hear them, even though they're talking at the same time. Well, it just doesn't work that way. And so, that you need to be able to let go of that transmit button so that you can hear again and the other station can transmit.
One of the things that is a common occurrence, all too common, are radio operators working events. Like with Utah SAG, you got a radio operator there at the aid station. They'll have an external microphone that they're on, and some radios are notorious where if you don't have the plug in completely, then it will transmit. And so you have what's called an open mic, a stuck mic. And sometimes it takes a while to find the person who is transmitting because while they're transmitting, no one else can use because we're all using repeaters, so one at a time type of stuff. So you need to be cognizant of other people, right? That's part of learning how to use the radio is how to use the microphones, the external microphones. Some people will take their radio and they'll go into the car and they'll sit down when their radio is on, and they'll put their PTT button will be pushed, and they'll be driving, and you can hear the radio going, and they have no clue that they're transmitting. So this is just very simple things that can be prevented.
Exactly. So you want to be aware of that PTT button. You want to make sure that you are releasing it to listen and you're not accidentally pushing it when you don't mean to transmit. So I have heard people do that where you're pretty sure that they're sitting on the microphone or the mic is sitting next to their seat and their leg is pushing against the side of it and hitting that PTT button. And so you can hear everything going on in the car. They have no idea that they're transmitting. So that is definitely something to think about and consider as you're working your radio. So again, like with mobile radios, the mic is separate from the radio itself. It's usually on a cable or a cord. The orientation of the radio obviously doesn't matter as the antenna is not directly attached to it. But you do need to think about how you're holding that microphone in front of your mouth. And do you need to be talking across it or directly into it? Depends on the microphone. Dan did give us an excellent presentation on the controls of four different common radios, including the Baofeng and the TYT TH350 and a couple of Yaesu radios. And that presentation is on the website. The video for it is on the website. You can go to this link and watch that presentation. And I highly recommend that if you have one of those radios, you do that because he will walk you through programming in a frequency, programming in the different settings, saving it to a memory, and all of that kind of stuff. That was done 2 years ago, February 2nd in 2023. So good presentation from Dan. All right. So let's talk about what the difference between simplex and repeater operation is for a second. So simplex operation, think of simplex operation as radio to radio communications directly. So I have a radio, you have a radio, there's nothing else involved. It's just you and me and our two radios. When I transmit, you receive. When you transmit, I receive. Now, there could be multiple radios listening. One thing to keep in mind is that you really don't know where that signal is going. Remember, it extends out from you in a circular pattern. So even though the person you're talking to might be ahead of you a mile away or something like that, the person who's a mile behind you, if they're on the same frequency, they're going to hear you as well. So the radios have to be within range of each other in order to work. And if you're working over a wide area with multiple people, you may need to relay, which means if, let's say, I'm at one location and Dan is at a second location and Sam is at a third location. Sam can't hear me directly, but he can hear Dan, and I can hear Dan. And so I can transmit something to Dan, and he can repeat it to Sam. And now my message has moved as far as Sam, right? So that's called a relay when you do that. You're depending on an intermediate station to receive your message and send it further along. So simplex is very simple, easy to use, easy to understand how that works. A repeater operation can be a little confusing for people. Let's talk about what a repeater is. A repeater is a specialized machine that has two radios attached to it. One radio is used for receiving and the other one for transmitting. And the two radios are on different frequencies with a defined offset that tells how far apart they are. So typically your repeater is going to be somewhere high, like on top of a building, or have a very tall tower or antenna mast, or it might be on top of a mountain. And it will typically have much wider coverage than your typical handheld radio. The other factor is a lot of these repeaters have 100 watts of power or even more, whereas your handheld is probably not going to have more than about 5 watts, and your mobile is probably not going to have more than about 50 watts. So you can get a repeater up on top of a mountain like that and cover a very large area. Repeaters allow you to talk to other stations much further away than you can reach with simplex. You don't need to see the other station. You just need to be able to see the repeater. It's just like the relay in simplex operation, except the relaying is happening automatically. So as far as the way the frequencies work, the repeater is listening on a particular frequency, and my radio is going to transmit on that frequency. The repeater is transmitting on a different frequency, and my radio is going to receive on that different frequency. So in the diagram here, we have Joe radio operator here, and he's transmitting on 147.720. The repeater receives that and retransmits it on 147.120. And mobile car radio guy is listening on 147.120, and he hears that. When he wants to talk, he transmits on 147.720. The repeater hears that and retransmits it on 147.120. And Joe radio guy over here on the left with his handheld hears that signal. So it allows me, even though there's a mountain in between us, it allows me to talk back and forth with other stations that are much farther away than I could reach in simplex operation.
So just so you know, the radio frequency that you see on your radio, that is always the receive frequency, okay? That is not the transmit frequency. So as a matter of fact, when I'm transmitting N7XDL, I am transmitting on that offset frequency. The repeater now is transmitting on the receive frequency that I'm looking at, okay? So that's why it's important to understand what the offset is. Otherwise, you're not going to be able to talk to the repeater. And if you don't talk to the repeater is not going to retransmit your transmission, in which case you're going to be talking to yourself.
So let's dig into that offset a little bit more. So the offset is the critical thing that makes repeaters actually work. It lets the repeater transmit and receive at the same time, even on the same antenna, without interfering with each other. The size of the offset is specific to the band. So typically on 2 meters, we're going to use 600 kilohertz offset or 0.6 megahertz. And it might be positive or negative depending on where that repeater is in the band. We'll talk more about that in a sec. On 1.25 meter, it's always a 1.6 megahertz negative offset, and 70 centimeters is always a 5 megahertz negative offset. Now, I say always, different countries might have different rules, right? They might use a different value, they might use a different offset direction. You don't know that until you know what repeater settings there are, and we'll talk about that in a bit. But the ones that I've just given are commonly used here in Utah and in the United States. The frequency coordinator for your area will be able to tell you what offset is being used. So
Stand by, Jim.
yeah, go ahead.
Go ahead.
Sometimes some of us participate in other services. So I belong to a volunteer group that has federally assigned frequencies, and we have repeaters. And our repeaters don't necessarily follow this. This is why you see on some of your radios the ability to set custom offsets. We have a repeater system, for example, that has a 4.25 megahertz offset. So it actually, the repeater actually brackets the 2 meter band. So we talk up to the repeater below the 2 meter band, and the repeater talks back down above the 2 meter band.
Yes.
Expand the entire band.
So in Utah, the frequency coordinator is responsible for even the offset. So Utah VHF, they have a blog on their website that actually talks about the offsets. If I go to New York, I know that I have to do plus 5 megahertz for UHF. It is dependent on the local, well, probably the state frequency coordinator.
Yeah, usually it's a statewide type of a thing. Or keep in mind, some states are bigger than other states. So depending on where you're at, sometimes multiple states will get together and a single frequency coordinator will set things up for multiple states. I think like what they call the Delmarva area, Delaware, Maryland, Virginia. I think there's a single frequency coordinator for that whole region. So, that's something to also consider. You need to know what's going on in the area where you're going to be operating. Okay, so let's talk about Mark's repeater. We'll just look at some typical repeater examples that you might use. So Mark's repeater operates on the 1.25 meter band, and the VHF Society page for our repeater says its frequency is 223.96 megahertz. That means the repeater transmits on 223.96, and that's what you tune your radio to hear the repeater. On the 1.25 meter band, the offset's always negative 1.6 megahertz. So the repeater is listening on 222.36 megahertz. That's 1.6 less than what it is transmitting on. Some radios will have you configure a transmit frequency. Others will have you configure an offset and a direction. Again, it depends on your radio. The repeater also requires a tone of 103.5. Remember, we talked about the tones before, and I said I'm going to talk about that in a minute. That minute has arrived, so we will talk about the tones. What are these tones? Sometimes multiple repeaters on the same or nearby frequencies have coverage areas that overlap each other, and you only want one repeater to hear you at a time, right? You don't want to be transmitting and if you're like right in between two repeaters that are on a close frequency with each other, you don't want both of them to hear you at the same time because your signal's not going where you think it's going quite often. So in order to limit which repeater hears you, the repeaters are configured to listen for a special tone or a digitally encoded value. The squelch on the repeater, remember how we talked about squelch and how if the squelch is closed, you don't hear anything. If the squelch is open, you hear the signal that's coming through. The repeater squelch will only open if it hears the tone it's looking for. So it will only retransmit your signal if you include that tone in your transmission. Tones are not used on simplex frequencies. So don't set a tone or don't use a tone on simplex. It's not, I mean, you could, but we generally do not do that. There are 3 different types of tones that are used. There's CTCSS, tone, and DCS. So CTCSS is continuous tone-coded squelch system. And that means the tone is transmitted by both the user's radio and the repeater. Now, when I say that, so I'm going to send my tone, the repeater is going to also send a tone. And if I have my radio set for CTCSS, my radio won't open the squelch and I won't hear that signal from the repeater unless that tone is present. If I don't have my radio set on CTCSS and I have my radio set on tone, it doesn't matter if the repeater is sending a tone or not. I'm going to hear it. Okay. When you're set for tone, you're sending a tone, but you don't care about any tone coming back to you. So the repeater is listening for that tone, but it either doesn't transmit one or you don't care if it does or not. And then DCS is a digitally coded squelch. There's a digital number that's encoded in that subaudible frequency, and that code has to match in order for the squelch to open on either the repeater or your radio, depending on how you're set up.
Let me just say a thing on the tones are not used on simplex frequencies. FRS radios is the exception. If you set the privacy channel
I'm going to
that
talk
they
about that in a
take.
second. I'll talk about that in a second, Dan. So
Okay, go ahead.
yeah, so you may hear these referred to as PL tones. Okay, people will say, well, it's a PL of 103.5. They were originally implemented as Motorola's private line system, and that's where PL comes from. Now, GMRS and FRS radios will call these privacy tones, okay? And you'll see the radio in the box and it'll say on the box 500 channels or whatever. Well, no, it's not really 500 channels. It's really the 22 channels of GMRS or FRS, but you've got a bunch of privacy tones that you can overlay on top of that. The thing that you need to know is there's nothing private about radio communications. The tones do not prevent others from hearing your conversation. If I set my GMRS radio to not require a tone, I'm going to hear everybody, regardless of what tone they're using, what PL they're using. I will hear them. Okay. So keep that in mind on the radio. Now, in some weird edge cases, you might find a repeater that needs one tone for it to listen to, and it sends a different tone that you want your radio to listen to. That doesn't happen often, but occasionally that will happen. Some radios have the ability to set a separate transmit tone and a separate receive tone. Other radios might not have that capacity. My Kenwood radios don't do that. They only want the same tone. If I set it for CTCSS, it's looking for the same tone as the one it's sending. If that repeater has a different tone on its output and I want to use that, I have to use two separate channels and both VFOs on my radio to be able to operate on that repeater. Now, what I probably will do is just use tone instead of CTCSS, and I won't care about the receiving the tone, right? I'll just receive anything that comes back. But I may get some unwanted interference if I do that. So that's something to think about and consider. Uh, your radio might have the ability to do that. It might not have the ability to do that. You'll only know that if you've read the manual for your radio and figured out how to program it yourself, right? So do that. I can't stress that enough. All right.
Just,
So
just 1 second, Jan.
yeah, go ahead.
I was just gonna make a comment on these alleged privacy tones on FRS. If you ever want a practical example of how these don't work, take some FRS radios and go to Disneyland. And, you know, everybody's setting their own PL tone so they can have a private channel where they block out, you know, the others, I don't know how many channels there are, how many tones there are. Let's say they try and block out the other 14 channels. All they're really doing is they're contributing to raising the noise floor, and they essentially make it so nobody can use the band because everybody's talking and they're blocking out all the people they want to hear, so everyone continues to talk over each other and then nobody hears anything. So they completely destroy the band in that area.
So basically, I know in Disneyland, you use an FRS radio, and the only time it works is when you can actually talk to them without the FRS radio.
Exactly. Right. That's definitely a problem. And when you're in an area where it's saturated like that, it can be practically unusable. You're better off to use your cell phone in that case. All right. So let's talk about another.
Hold up, Jan. We got another question. Go ahead.
Okay, go ahead.
Stan has one.
Yeah, I'm kind of an old man, 68 years, and I have a 50-year-old Kenwood, and it didn't come with the tone capability. So I built a tone generator for everybody that phones and says they can hear the tone when I transmit.
Right.
Does the tone, is it present all the time on normal radio?
Yeah. Yep.
So a lot of modern radios will
Well-
actually mask out that tone if it's there. so that you don't hear it. But your radio, your old radio doesn't know how to do that. So you might hear that. You might be more likely to hear a tone on that radio because of that fact.
Well,
So
they put mine on.
Yeah, yeah. Some repeaters, all they need is just the tone at the very beginning, and then you can stop with the tone, but you've already
open the
opened the
squelch.
squelch, as it were, on the repeater, and you continue on. Then when you stop, the repeater is then now listening for the tone again. So it depends on the repeater. I've seen it both ways.
Yeah. So all good, interesting points about the tone. So the main thing to remember, it's not really private. It's mainly to try to prevent you from impacting people that are slightly out of your range that might still be able to hear some of your signals. So that's why the tones are configured. And the frequency coordinator will decide what tones are used in what places depending on what's already in that area and what's close around it. So those are things that are set up when that repeater is configured, and they'll stay that way as long as the repeater is there. All right, so let's talk about Farnsworth Peak Repeater. So this repeater is owned and operated by UARC, which is the Utah Amateur Radio Club. This repeater was first brought online in 1980. While UARC doesn't put any restrictions on the use of the repeater, if you are a regular user of this repeater, you might want to join UARC so your dues contribute to maintaining this repeater. Murray Amateur Radio Club, we don't have any dues, so the city has been gracious enough to support us in maintaining our repeater. And boy, we've needed some help along the way. So, it's been really good for us that they have done that. But UARC, they maintain several different repeaters. And if you are a frequent user of those repeaters, it would be nice for you to join the club. And even if you don't go to any of their meetings, because their meeting happens to be on the same night as our second Thursday meeting, and we'd much rather have you come to our meeting than go to theirs. But you still could support them by joining their club and paying your dues there. This repeater transmits on a frequency of 146.62, and so we often call it the 62. You'll hear people say, "Well, I was listening to the 62 the other day." This is what they're talking about, is this Farnsworth Peak repeater. And so because it's using a 600 kilohertz negative offset, the repeater itself receives on 146.02 megahertz. Now, when you see this in the repeater list, if you go to that website that I posted earlier, and you will see this notated as 146.62 with a little minus sign in the parentheses. If it's a positive offset, there will be a little plus in between those parentheses. And that's how you know if it's positive or negative. You have to look that up and see, are they doing a positive offset or a negative offset? And again, in the 2 meter band, it just depends on where in the band that repeater happens to be. It might be positive, it might be negative. In Utah, at least, all of the 1.25 meter and 70 centimeter repeaters are going to be a negative offset. The Farnsworth repeater does not require any tone to operate. This was very fortunate for me when I first got licensed, because a friend of mine who convinced me to go take the test, he loaned me a radio, and the tone generator on that radio was broken. And so this was the only repeater I could get into because it did not require a tone. So I used this extensively when I first got licensed quite a few years ago. This repeater is at about 9,000 feet on the mountain, and that gives it excellent coverage. It gets out at least 100 miles, if not more. It depends. The history of the repeater, there's a nice write-up that Gordon Smith put together. Gordon Smith is a silent key, which means he's passed away. He's no longer with us on this earth. But he wrote up a nice description of how they planned this repeater, how they put it up, things that happened to it over the years. And it's really quite interesting because the repeater's receive antenna is about 400 feet away from the transmit site. So the reason for that is all detailed on this 62 RPT page on the UARC website. So check it out if you're interested. It's an interesting read to find out about how this was done back in the early 80s and things that have happened to it over time. But it's a good repeater. You'll hear a lot of morning and evening freeway traffic on this repeater as people are talking on their commutes. So very good repeater, has really wide coverage. Let's talk about another set of repeaters, the Intermountain Intertie. Dan alluded to this as being one of the linked repeater systems in Utah. This is a repeater system or a network. It has 31 repeaters and has coverage over Utah, Idaho, Southwest Wyoming, Arizona, at least Scottsdale, Flagstaff, and Phoenix area, Nevada, primarily the Las Vegas area, and Oregon, the Ontario, Oregon area. Uh, this is a set of different repeaters that are all linked together using radio. So when you key up your radio here in Salt Lake or in Murray, and you're on the frequency of one of these repeaters, that is going to key up all of these 31 repeaters in the network. And whatever you say is going to be distributed out across all of those repeaters all at once. And it's actually pretty cool. You think about how that all works. Uh, the system can also have separate links brought up into Montana and California as well. Those links are not up all the time. The ones that I mentioned before, the states that I mentioned before, are always online. And the system is operated and coordinated by the Utah VHF Society, and it's open to all hams. Again, if you use it a lot, you might want to become a member of the Utah VHF Society. In fact, it's a good idea to become a member of the VHF Society anyway, because then you're supporting the frequency coordination within Utah. I would recommend doing that. This system has multiple repeaters. Each of them use a different frequency. Most of them use a 100 hertz tone. There are a few oddballs that are different. There's also at least one radio on there that is not a repeater, but it's what they call a remote base radio. And so it doesn't actually repeat. So if you're in that area and you're talking to it, other people in that area may not be able to hear you, but people out on the intertie will be able to hear you. So that can be kind of confusing sometimes. In Murray, there are two repeaters on this system that you can hit, the Snowbird and the Farnsworth one. So there's one of these up at Farnsworth, the same general area as the 6.2 repeater, and there's one at the top of Snowbird at the tram building at the top of the mountain. There's more information on the Utah VHF Society website from that link right there. There's maps, there's pictures, there's diagrams that show the coverage, and it's really a pretty amazing system. So you can definitely get on that and talk to people quite a ways away using just your handheld radio. So it's pretty slick. All right, so here I am. I've got my radio. I've got it all programmed, ready to go. I'm about to push that PTT button. Now, what do I say? Well, the first thing to remember is everyone made their first transmission once, and you're no different from them. Okay. Mic fright is a real thing. That means you are about to push that button, and it's scary to think about. I'm going to push this button, and people all over the place are going to hear what I'm saying. What if I say something wrong? What if I mess up? That's just part of life. Okay. The second thing to remember about talking on the radio is you're talking to your friends. In amateur radio, we use people's first names and call signs almost exclusively because we're all friends with each other and we're all on a first name basis. Now, even the jerks are still your friend. Okay. The third thing to remember is you will make mistakes, but so does everybody else. I've heard hams with 40 years of experience make mistakes, call on the wrong repeater, screw up their call sign. When it happens to you, it's no big deal. Don't worry about it. Just fix what you're saying, say it correctly, and move on. It's not a bad thing to make a mistake on the radio. It's okay. Yeah, you as long as you're staying within the legal limits, the rules of what you're allowed to talk about, don't worry about if you flub up your call sign or if you transmit on the wrong repeater. I do that all the time with my mobile radio because I don't notice that it's on the B side instead of the A side, and I'll make a call and it's going out to nobody. So I just quickly say, "Oh, sorry, KD7ZWV, wrong repeater," and I switch over to the other one and off I go, just like nothing happened. So how you start your call depends on who you're talking to or who you want to talk to. And if you're joining an existing conversation, you want to wait for a break in the other people's transmissions and say your call sign. If they don't hear you, just wait for the next break and try again. If they do hear you, even if they couldn't make out what you said, they'll say something like, go ahead, break, or they'll ask for the station who just tried calling to go ahead. And what you'll be doing is joining a conversation or making a round robin. So when you say your bit, you pass it on to the next operator in line and they pass it to the next and so on. Think of it like a big circle. And eventually it comes back to you and you go again. So you don't want to do kind of if you're talking to two other stations, you don't want to be like the key and talk to one station and then talk to the other station and then talk to one station and then talk to the other station. You want to talk to the one station all the time. He'll talk to the next station and that station will talk to you. You do this in a circle and that way everybody gets to talk. Everybody gets to say what they want to say. Okay. So that's kind of important for when you're doing this with multiple people on the radio.
Hey, Jan,
Yeah, go ahead, Dan.
yeah, we need to wrap things up.
I've only got a couple of slides left. I can probably run through them pretty quick if you guys can.
Okay, go
in a
ahead,
couple of
real
minutes.
quick.
All right. So if you want to call a specific person, key up, give their call sign, and then say from and your call sign. If they hear you, they'll come back and you can talk. If they don't hear you, then they weren't there. And if you want to talk to anybody, you don't care who you're talking to, you can either call CQ, say CQ and your call sign, or if you're on a repeater, just say your call sign, or a lot of people will say your call sign and the word monitoring or listening. If someone hears you and wants to talk, they'll come back and you can have a chat. Okay. So what do you want to talk about? Talk about anything except the restricted topics. Don't swear. Don't talk about anything that costs money unless you're trading ham radio gear. Don't sing or transmit any music on the frequency. If you got another hobby like photography or something like that, talk about that. If the weather's weird, talk about that. We'll talk about whatever they want to talk about or whatever they're already talking about. Talking about the traffic is pretty popular, or talk about how their radio sounds, or what kind of radio they have, or what kind of antenna they have. And when you're done, if you're in that round robin, just say, hey, I'm out of here after this time around. I'll stick around for one more, and then I'll be clear and give your call sign. If you're only talking to one other person, say you're going to be clear when they're done, give your call sign, and make that your last transmission. And it is nice to say 73 to your new friends. Couple more things to go through just really fast. What does the thing that they said actually mean? Sometimes you'll hear a word that you don't recognize. It might be a Q signal or a pro sign. These are some common ones. QSO is a conversation. QTH is where you at. QSY means change frequencies. It might be a pro sign like 73. 73 means best regards. CQ is calling any station. Your YL is your young lady or your girlfriend. Your XYL is your ex-girlfriend or your wife. An OM is an old man. You might hear people say hi, hi. That means that they're laughing. And then let's see. We've got some other presentations online about the language and things that you'll hear on the radio. Go ahead and watch these presentations and you'll get a lot more detail on these codes and phrases and things that you're likely to hear. All right. So what's next? Get out there, turn your radio on and talk to people. You can do it. We all did it. Get out there, get on the radio and have fun. And that's the end of the presentation.
Thank you very much, Jan. Any questions? Okay.
All right.
I'm going to give you a round of applause.
I'm going to stop the recording and